Now that you have understood how the addition works in the linked list and you have understood how deletion works in the linked list, let's just code out the deletion code. So let's just say you wanted to delete a node. So let's keep it a bool and let's call it delete, and let's give it an integer n. So what is the integer n? It is going to tell us which index of the linked list is to be deleted. So the indexing will start from 0, and to aid this we'll keep a count of the number of total nodes that we have. So in the add code we'll just keep incrementing the count, right? And in the delete code we'll actually remove it. So if n is greater than or equal to count, then that particular linked list does not actually exist. So that particular node does not exist, so we need to return false, and that's all. And if in case it does exist, we need to go to the node that is just before it, right? And then remove its existence from this node and take its next pointer and plug it into the given node. So let's just understand it using the example. So let's say this is the first node and it points to this second node, and let's just take a different character here, and this points to a third node like this, let's say, and so on. So for now, let's say we want to delete this node. Then what we need to do is go here and remove this reference. So let me just for the sake of understanding the steps, what we are doing is taking this list and removing this, then we are deleting this complete thing, and then we are stuck because we do not have a pointer here. What can we do? So this part is actually disconnected from the linked list. What do we need to get here? We need this ampersand thing. So what we are doing is actually copying this ampersand thing down here and then removing these links directly by deleting this node, and we are creating this link because this ampersand is here. So that node has been effectively deleted without removing the unnecessary connections and without disrupting the rest of the linked list. So let's just go ahead and code this one. So what is happening is we are moving ahead n minus 1 times. So we are at the 0th node, and if we want to delete the first node, we are moving 0 times. If we want to delete the second node, we are moving 1 time to second index node, right? And if we are deleting the index 0 node, we are changing the head. So let's just code that one out first. So if n is 0, then let's just do head is actually equal to heads next. So there is an initial pointer pointing to head. So the head, you can actually assume like there's a dummy value that's here, and there's an actual value pointer called head that is here, and this marks the beginning of the linked list. So this is the the 0 indexed node. So what you are essentially doing is taking this value and placing it in the front of head so that it goes to the very next value. So this is what you need to do in this case, and return true here. So you can return true. Else what you are doing is you need to move a few steps. So what you need to do is for int I equals 0, I less than n minus 1, I plus plus, you are actually moving ahead. So what you're doing is creating a node pointer, let's say temporary, and actually initializing it by head, and then what you're doing is moving ahead. So head equals head next, and once you're done with this, you're basically so you're not moving head, you're actually moving temp. So head is the head is the actual class variable, and we are actually moving the temporary variable that we created just now. So we are moving the temporary variable to the next position n minus 1 times, and when we are at the node just before the node that has to be deleted, the following steps need to be performed. So temp so if temps, so we have checked that the temps next exists. So what we are going to do is the next of temp is going to be deleted somehow, right? And we need to we need to completely work so that the node is deleted indeed. So what happens is we need to delete the reference to that node and go ahead and move the pointer ahead. So let's just store the next of the node to be deleted. So let's call it new next, and it's gonna be temps next. That is the next node that we have to point to. And what we are doing right now is actually taking the value that is to be deleted. So this is the point to the node that is to be deleted. So that's going to be temp next, right? And what we're going to do is temps next is now going to be new next. And now we have essentially removed the node that we needed to remove. But is this all that we needed to do? Well, no, because we have a memory that is to be released for the usage of other nodes. And how can we do that? We need to delete this point, right? And this will delete the pointer that is storing this memory, and hence this memory is now removed, right? So let's just understand what all we did here. So the thing is, we created a new temp to move to the previous node of the deletion. Then we took into the new next the next place of the deleted node, and then we fixed everything for the current node so that the deleted node does not break the chain, the linked list, and then we deleted the previous point in the linked list. And this concludes the usage of delete. And let's just do, so in this we have 0 1 2 3. So let's delete something at the position 2. Let's delete position 2, and let's print everything out, and let's hope that it works out. So let's save, and let's go ahead and compile. So okay, so there was some problem in compiling, so let's just go ahead and see what the problem is. Oh, all right, so there's no I think that's all, and let's just go ahead and compile. Okay, so right, probably I didn't complete any function here. So expected unqualified ID before this, and unqualified ID before delete. So yeah, so since delete is a reserved keyword, let's call it ldelete. Here as well, let's call it ldelete. So let's save, and right, so let's just return true here as well. Okay, so this should do. Right, so let me just close this down and increase the size of text here. Right, so let's just go ahead and clear, compile stuff out, run this, and I think the deletion code did not work here. So let's just go and see what is the case, why it did not work for us. So let's see why it did not actually work. So we go to the previous node of the movement, right? So we actually wanted to delete the second, so 0 1 2, so we actually wanted to delete 19. What happened was we moved one time, right? So we moved one time, and when we moved one time we were actually at the node 14, right? So we were at the node 14, and the new next has been stored, and the 14's next has been made 19's next, which had to be 67, and this should have worked. So let's just see why it did not work in this case. So temp is actually head, temp moves ahead, stores everything out, and this changes the linked list that we had, and we delete the thing. I think this should have worked. So I think what we haven't done here is a count minus minus, which has to be performed. So let's just remove this and remove this, and also let's just return true in the end, although that does not make a difference too much of it here. So count plus plus is the thing that should have been working. It is, and we haven't initialized count to be 0 yet, so that could be one of the things. So let's just go ahead and compile, and let's just run, and you can see this code works now. I hope you have understood it, and in the next lecture we'll go ahead and do making a stack using a linked list, and then you'll get your task assignments. Good luck, and I'll see you in the next video.